Hello viewers, this video is about the simulation of mechanical translational system using differential equation. Let us consider this simple mechanical translational system, which consists of a force, a mass, a dashboard, and spring. So we can write the differential equation for this system by Newton's law. The supply force, that is applied force, is equal to the sum of all the opposing forces. So the applied force F is equal to the opposing force due to the mass, due to the dashboard, and due to the spring. So F will be equal to m into d square x by dt square, b into dx by dt, and k into x. We can represent dx by dt as x dot, so that we can write the F is equal to m into x double dot plus b into x dot plus k into x. So we can write m into x double dot equal to f minus kx minus bx dot. So x double dot, we can write it as 1 divided by m into f minus kx minus bx dot. So this is the differential equation where we have derived the d square x by dt square equal to 1 by m into f minus kx minus bx dot. This equation we are going to represent by means of a block diagram. So in the block diagram, the input is the applied force, output is the displacement, which is x. Now we are going to represent this equation in terms of the blocks. So we need to, this is your applied force, that applied force minus kx minus bx dot we are going to represent now. So in order to get minus kx, we are taking the feedback from the x, and that is multiplied with again k, and it is given to a summing point. Then x dot, it is taken as again, it is taken from x dot, we are getting the signal, and that is multiplied with the p, that is a spring, that is dashboard constant, viscous coefficient of the dashboard, and b into x dot is again given to the summer. So the output from this summing block will be k into x plus b into x dot. X dot, if it is integrated, we will get the x. Now we have to subtract the summation of these two from the applied force. So we are taking the sum of bx dot and kx, and we are giving it to a summing block where f is given with the plus sign, and this will be given with minus sign. That should be multiplied by 1 by m to get the x dot. So output of this gain block will be x double dot, which when integrated by one time will give x dot, which when it is integrated, it will give x. So output of this gain block will be x double dot, which is integrated to get x dot, which is again integrated to get x. So we have represented the differential equation with the help of the block diagram. Now we are going to simulate this mechanical translation system, which we have represented by means of the block diagram. This is now being constructed in the MATLAB. So before drawing the circuit, we have to open the MATLAB. So once if the MATLAB is opened, we'll get this screen. Then we have to click on the Simulink library browser. Once if the browser is opened, we have to create a blank model. So click on the blank model, and then we will get the screen like this. Now we are going to draw the block diagram. And this entitled in this new block, new model. So, which was shown here, which is shown here. We have taken the untitled new model, and this block we are going to construct here. So to draw this block diagram, we need a summing point, two summing point. So take two summing point, because in the block diagram we have two summing points. So control press on this summing point and control R to rotate the summing point. One summing point will have plus and minus symbol. So we'll change the plus symbol to minus symbol. So in a default case, the summer will have both the symbols as plus symbols. If we want to change the symbol, we can click on that and we can change the symbol. So for first summing point, we need to use one plus symbol and one minus symbol. So we have taken plus and minus here. Then we need three gain blocks. One to have 1 by m, another one to have b, and another one to have k. So type gain, and let us right click and drag to get two more gains. One gain is nothing but 1 by m, and another gain block is nothing but b. Another gain block is nothing but k. Just bring constant k. We can rotate the gain blocks to get like this. So and then we need two integrators. So type integrator. Right click and drag. Right click on the integrator and drag it to get the another one. So the components, that is the block, should be connected as given in the block diagram. Output of the second integrator is nothing but the output x. We will connect all the blocks. So input force, we can give either in terms of step input or by means of a constant block. So let me use a constant block now. And let me take the input force to be 10. So in order to see the output displacement, we need to use a scope. So this point is nothing but x dot, that is dx by dt. This is nothing but x. output of the 1 by m gain block is d square x by dt square. Now we can we can take the mass to be equal to 2. So this will be 1 by 2. And let us take B to be 1 and K to be 3. And now we can run this model. Let us check the output displacement. So we have obtained the output displacement in this patient. We can even increase the value of the B to 2 and check how we are getting the output. So if we change the B value, the output oscillation, it is getting damped out fast. So by changing the values of M, B, and K, the output displacement waveform will change. So we have constructed the block diagram of the simple mechanical system by using the differential equation. This is a simple mechanical system which consists of single mass, single dashpot, and single spring. We can extend this even for two mass system also. So likewise, if you have any mechanical system, we can represent that mechanical system by means of a differential equation, and we can represent that equation by means of the block diagram, and we can simulate it in the MATLAB Simulink environment. Thank you.